Regression modeling. Regression modeling is a powerful statistical technique used to understand the relationship between variables and make predictions. We will explore linear regression and its various applications using the R, Python programming languages. Introduction to linear regression. Linear regressions explore the linear relationship between a dependent variable and one or more independent variables. It aims to find the best fitting line that represents the relationship that allows us to predict the value of the dependent variable based on the independent variables. First is relationship analysis. Determines the strength and direction of the relationship between variables. Second is predictive modeling. Develops a model to predict the value of dependent variable based on independent variables. Simple linear regressions in R and Python. Simple linear regression involves one independent variable and one dependent variable. We'll use R and Python to perform this analysis, estimate the model coefficients, and evaluate its performance. In R, the M function for model creation, summary function for model summary, and predict function for predictions. And in Python, state states model dot formula dot API dot OLS for model creation, model dot summary for model summary, and model dot predict for model predictions. Multiple linear regression in R and Python. Multiple linear regression extends similar linear regressions to include multiple independent variables. This technique helps us understand the combined effect of multiple factors on the dependent variable. First is model creation. MNR state models.perfume.api.ols in Python. Model summary. Summary in R and model.summary in Python. Model evaluation. Multiple matrices include R squared, adjusted R squared, p-values, and confidence intervals. Access in model fit and diagnostics. After fitting a regression model, it's crucial to access its fit and diagnose any potential problems. This helps ensure the model is reliable and provides accurate predictions. R squared measures the proportion of variations in the dependent variables explained by the independent variables. Adjusted R squared penalizes the model for including unnecessary independent variables. F statistic tests the overall significance of the model, indicating whether there is a relationship between the dependent and independent variables. P-values assess the statistical significance of individual independent variables. Stepwise regression techniques. Stepwise regression is a method used to select the optimal set of independent variables for regression model. It involves inter intermittently adding or removing variables based on their statistical significance, aiming to aiming to achieve the best model fit with fewest variable. Forward selection starts with an empty model and interrelatively adds the most significant variable to at each step. Backward elimination starts with a full model and it it relatively removes the least significant variable at each step. Stepwise regression combines both forward and backward steps, adding or removing variables based on their significance. Implementing stepwise regression in R and Python. R and Python offers function for implementing stepwise regression. These functions automate the process of adding or removing variables based on predefined criteria. In R, step function for stepwise regression, direction is equal to forward for forward selection, direction is equal to backward for backward elimination. And in Python, State state modules, as you can see on screen, for model creation, model.fit for model fitting, and model.summary for model summary. Interpreting stepwise regression results. The results of stepwise regression provides information about the selected variables and its significance. By analyzing the coefficients, p-values, and r-squared values, we can interpret the relationship between the selected variables and the dependent variables. Coefficients indicate the strength and direction of the relationship between independent variable and the dependent variable. P-values access the statistical significance of each independent variable. R squared Measures the proportion of variation in the dependent variable explained by the selected independent variables. Evaluating final regression models. After performing splitwise regression, we need to evaluate the final model performance. This involves accessing the model fit, making predictions, and interpreting the results. Model evaluation. Access model fit and diagnostic matrices. Second is prediction. Make prediction using the final model. Third is interpretation. Analyze the results and draw conclusions. Applying regression to a case study. Let's apply regression techniques to a real world case study. We will explore a data set, building a regression model, and interpret the result to gain insights and make predictions. Data exploration. By understanding the data is essential before building a model. And building model utilizes the chosen regression techniques to build a model. Thank you for watching my video. Please do like and share.